All right, I'm speaking to Hannah and Abby, and sorry you're not with us this day, this momentous day, last day before the big trip for you two anyway. So we are putting on page 139, we found a spot that didn't have anything, so we had to squeeze something in there. So not 141, that's coming in a minute. Page 139, we did this, and we did it right with elimination. I did not show the steps, but you can prove to yourself by elimination 0 equals 7. That is not normally the case. So what that means when you've done the math correctly and all the variables disappear and you come up with a statement that is not true, that means that the lines are parallel to one another. So they never intersect. So therefore, we do have no solution to that one. So indicate that case. And now try this one. You have to squeeze again. I'm putting the squeeze on.
Is this the last one?
Yes, this was the last squeeze for this page. All right, try that. And you out in video land, try this one. Again, by elimination, please multiply the top one by either -1 or negative
0.
negative 2 or something.
So does that mean infinite solution?
Yeah, so what you
It's the
get,
same one.
what'd you get, Allie?
0 equals 0.
0 equals 0. So if you end up with a statement, the variables are gone, but it's a true statement. It doesn't have to be 0 equals 0. It could be 7 equals 7 or something similar. That means that the two lines are first this one, and then the second one in blue is this one. So how many intersection points?
Infinite.
Infinity. So infinite, so the number of solutions, and that's about all we can say. So those two special cases I needed to add on. All right, normally our systems intersect in one point and we get x equals 3 or whatever, we substitute back, we get y equals 4. And the answer is the intersection point 3, 4. On your green cards, which I collected, so someday Hannah and Abby, bring your green cards to me completed. Abby, your green cards are here. I did shine a light on them, so if you would do them someday. All right. Did any of these odd situations show up on your green cards?
Yeah.
Which one?
The parallel lines.
So this was did you notice a no solution had
Yeah.
happened?
Yeah.
Okay. All right. Very good. Now page 141 for just a few minutes. And turns out most of our math career so far this year has been in X and Y. So let's observe an XY plane. So can you draw an XY plane on your page? And now we're going to take that good old XY plane, and remember it has numbers along this axis and numbers along this axis. And I'll actually eyeball them, draw them in, like as if it was a graph paper. You don't really have to.
Are we going to add Z?
Just for a moment.
Yeah.
So let's say I'm going to take this XY plane, do you see it in my hands? And I'm going to throw it on the floor. So now, when I draw it, it's hard to draw 3D on a 2D board, but now this is the X and this is the Y, and does it look now like it's laying down on the floor?
Wait, how did you do that? Yes.
Alright.
That was really
Math
good.
teachers are always like, "Oh, I'm so bad at this," and
Right.
then they
Here's
just do it
the Y. Let
perfectly.
me make it dark, and here's the X. Alright, so it looks like a linoleum floor with checkers. These used to be all the rage. Alright, so what comes rising up from the origin that you've seen in the past? The Z-axis. Alright, I'm going to dot it below because it goes underneath this so-called floor. And it comes up like that. Z. So it's hard to draw, just do your best. And I want to say, let's graph a point, 2, 3, 4. I took a long time to figure out a number to graph. 2, 3, 4. So now we have an x coordinate, a y coordinate, and lo and behold, a z coordinate. I slash my z's, don't let that confuse you, it just keeps my 2's separated from my z's. So, I'm from the origin, I'm going to go out 2 on the linoleum floor on the x-axis, and then I'm going to go up 3 on the linoleum floor in the y direction. And then I'm going to rise from the floor 4. That's where I'm kind of guessing. 1, 2, 3, 4. So if this is 4 up off the floor, then this point is 2, 3, 4. So that's a point in 3 space, and the problems today are actually going to have x, y's, and z's in it, but they're going to be in equations. It's almost impossible to graph an equation like this in free space. I'm sure there are people that can do it, and if we took a lot of time, we could do it as well, perfecting our drawings, but we'd have to find the slope in 3 space, and it'd just be a very, very big challenge. I guess we could find 2 points in 3 space, draw them, and then connect them. That would be the simplest. So we're not going to actually draw them, but I want to be aware that we are switching from 2D space to 3D. Alright, so I'll leave that picture there for inspiration. Alright, consider yourself inspired. Alright, what we're going to do today, and this won't get too far in this task, we'll pick it up actually when Hannah and Molly and Abby get back, so we'll actually wait for them. We'll pick this up way down the line after Easter and the return of the trip.
April 22nd.
So Bailey, Hallie, we'll just do a different topic next week. And we only have shortened classes Monday, Tuesday, Wednesday, Thursday, and then I think a normal one on Friday. So, so we'll have math light, but we will have math. So, all right. Write down this one. We're on page 141, and you can call it a system of 3 equations.
Did you just say we have a half day Friday? Or was that
A full day.
Oh, a full day. I heard half day.
That's quite
It's like a 2-hour delay day, Monday, Tuesday, Wednesday, Thursday. Not that you come in late. It's just that you get here late. So save some brain space for me. All right. X minus 2y plus 3z equals 9. Then we're going to do y plus 3z equals 5. And z equals 2. All right. You've seen these before somewhere in your bright. I was going to try to say deep dark, but a deep bright math past. So there's nothing dark about this. So can you reach back into your past or even just reason how you might solve this equation? You want to start down at the bottom.
Substitution.
Yeah, substitution. Right, why? Because we know from the very beginning what z equals. So where should we go? What's the most logical place to put it? Pardon?
The middle.
The middle one, because
Why?
And then you put
right.
both
So
of
go
them.
ahead. We're going to call that. We're going to give it a name. How about this? Back substitution. So let's go ahead. Go ahead, and if you would do the work for me and tell me what y is.
-1.
Is that
Yeah.
confirmed?
Yeah.
All right. So we got z equals 1. When we put 2 in for z, it became a 6. A 6 flew over, became a -1. So now we have y equals -1. And now we have 2 things to back substitute into the first one. So if you would,